Chapter 5, Goods and Financial Markets, the Islm Model. In Chapter 3, we learned the determination of output in the goods market in isolation, taking the interest rate as given. In Chapter 4, we learned how interest rate is determined in financial markets in isolation, taking output as given. However, the interest rate affects output through investment, as you will see in this chapter, and output affects the interest rate through money demand. So it is necessary to consider the simultaneous determination of output and interest rates. In 1937, John Hicks and Alvin Hansen developed the ISLM Investments Saving Liquidity Money Model to explain Keynesian analysis of how goods and financial markets interact to determine output and interest rate simultaneously. This requires simultaneous equilibrium in the goods and financial markets. Chapter 5 Outline, Goods and Financial Markets, the ISLM Model. Section 5.1 looks at equilibrium in the goods market and derives the IS relation. Section 5.2 looks at equilibrium in the financial markets and derives the LM relation. Sections 5.3 and 5.4 put the IS and the LM relations together and use the resulting ISLM model to study the effects of fiscal and monetary policy, first separately and then together. Section 5.5 introduces dynamics and explores how the ISLM model captures what happens in the economy in the short run. How does the ISLM model fit the facts? If you remember one basic message from this chapter, it should be, in the short run, output is determined by equilibrium in the goods and financial markets. Section 5.1, the goods market and the IS relation. In the model developed in Chapter 3, investment was assumed to be constant for simplicity. In fact, as equation 5.1 below shows, that investment, represented by uppercase letter I, depends on production Y or sales, and the interest rate, represented by lowercase I. We continue to assume that inventory investment is zero, so sales and production are always equal. As a result, Y denotes both sales and production. I equals I within brackets Y comma I with a plus sign under Y and a negative sign under I, as equation 5.1. The plus sign under Y and the minus sign under I indicate that an increase in sales leads to increase in investment, and an increase in interest rate leads to a fall in investment. Note, now that investment is also a function of output for a given value of the interest rate, demand is an increasing function of output for two reasons. Increase in output leads to increase in income, disposable income, and hence consumption. Increase in output also leads to increase in investment. So equation 5.2 below gives us the equilibrium condition in the goods market. It is called the IS relation. Y equals C within brackets Y minus T plus I within brackets Y comma I plus G, equation 5.2. Equation 5.2 says Y equals C plus I plus G, where C is a function of disposable income Y minus T, investment is a function of output Y and interest rate I, and G is determined by government as a matter of fiscal policy. Determining output using the Keynesian cross diagram. As before, Measure the demand for goods Z on the vertical axis and income and output Y on the horizontal axis. Demand is an increasing function of output for two reasons. One, an increase in output leads to an increase in income and thus to an increase in disposable income. The increase in disposable income leads to an increase in consumption. 2. An increase in output also leads to an increase in investment. This relation between demand and output for a given interest rate is represented by the upward sloping curve ZZ. Because we have not assumed that the consumption and investment relations in equation 5.2 are linear, ZZ is in general a curve rather than a line as shown in figure 5.1. However, all the arguments that follow would apply if we assumed that the consumption and investment relations were linear and that ZZ were a straight line. ZZ curve in figure 5.1 shows that demand for goods is an increasing function of output. Slope of ZZ is less than 1, assuming that increase in output does not lead to a one-for-one increase in demand. Equilibrium requires that the demand for goods be equal to output. On the graph, equilibrium is at point A, where the 45-degree line cuts the demand curve. This shows equilibrium in the goods market for a given interest rate. The equilibrium level of output is given by Y. Deriving the IS curve. We have drawn the demand relation ZZ in figure 5.1 for a given value of the interest rate. In figure 5.2, we derive what happens if the interest rate changes. Suppose that in figure 5.2a, the demand curve is given by ZZ and the initial equilibrium is at point A. Suppose now that the interest rate increases from its initial value I to I prime. At any level of output, the higher interest rate leads to lower investment and lower demand. The demand curve ZZ shifts down to ZZ prime. The new equilibrium is at the intersection of the lower demand curve ZZ prime and the 45-degree line at point A prime. The equilibrium level of output is now equal to Y prime. In words, the increase in the interest rate decreases investment. The decrease in investment leads to a decrease in output, which further decreases consumption and investment through the multiplier effect. Using figure 5.2a, we can find the equilibrium value of output associated with any value of the interest rate. The resulting relation between the equilibrium output and the interest rate is drawn in figure 5.2b. The second graph at the bottom plots the relationship between equilibrium output Y and the changing interest rates I. Figure 5.2 shows the derivation of the IS curve. In figure 5.2a, an increase in the interest rate decreases the demand for goods at any level of output, leading to a downward shift of the ZZ curve and a decrease in the equilibrium level of output. Figure 5.2b plots interest rate I on the vertical axis and output Y on the horizontal axis. Point A in figure 5.2b corresponds to point A in figure 5.2a, and point A prime in figure 5.2b corresponds to A prime in figure 5.2a. Equilibrium in the goods market implies that an increase in interest rate leads to a decrease in output. This relation between the interest rate and output is represented by the downward sloping curve in figure 5.2b. This curve is called the IS curve. Shifts of the IS curve. The IS curve gives the equilibrium level of output as a function of the interest rate. It is drawn for given values of taxes and spending. Now consider an increase in taxes from T to T prime. At a given interest rate I, disposable income decreases, leading to a decrease in consumption, leading in turn to a decrease in the demand for goods and a decrease in equilibrium output from Y to Y prime. The IS curve shifts to the left. At a given interest rate, the equilibrium level of output is lower than it was before the increase in taxes. Figure 5.3 shows shifts of the IS curve. Changes in factors that decrease the demand for goods for a given interest rate shift the IS curve to the left. Changes in factors that increase the demand for goods given the interest rate shift the IS curve to the right. Changes in G, T, or C0 will shift the IS curve. Increase in T or decrease in G or decrease in C0 shifts IS to the left. Decrease in T or increase in G or increase in C0 shifts IS to the right. Use Keynesian cross diagram to see how this happens. Conclusion. Any factor that, for a given interest rate, decreases the equilibrium level of output causes the IS curve to shift to the left. We have looked at an increase in taxes, but the same would hold for a decrease in government spending or in consumer confidence, which decreases consumption given disposable income. Note two important points about the IS curve. 1. Downward sloping. So equilibrium in the goods market implies that an increase in the interest rate leads to a decrease in output. 2. Shifts of the IS curve. Changes in factors that decrease or increase the demand for goods given the interest rate shift the IS curve to the left or right. Section 5.2 Financial Markets and the LM Relation. Recall Chapter 4 where you saw the equilibrium condition in the financial markets given by the condition money supply equals money demand, or M equals $Y times a function of the interest rate as shown on the slide. Divide both sides of the equation by the price level P. This gives us equation 5.3 below. M over P equals Y times a function of the interest rate, which says real money supply M over P equals real income Y times a function of the interest rate I. Equation 5.3, which says real money supply is equal to real money demand, is the LM relation. In equilibrium, real money supply equals the real money demand, which depends on real income Y and the interest rate I. The notion of a real demand for money may feel a bit abstract, so an example will help. Instead of thinking of your demand for money in general, think of your demand for coins. Suppose you like to have coins in your pocket to buy 2 cups of coffee during the day. If a cup costs $1.20, you will want to keep about $2.40 in coins. This is your nominal demand for coins. Equivalently, you want to keep enough coins in your pocket to buy 2 cups of coffee. This is your demand for coins in terms of goods, here in terms of cups of coffee. Figure 5.4 shows the LM curve. The central bank chooses the interest rate and adjusts the money supply so as to achieve it. LM is horizontal at the interest rate chosen by the central bank. In the rest of the book, we shall think of the central bank as choosing the interest rate and doing what it needs to do with the money supply to achieve this interest rate. This will make for an extremely simple LM curve, namely a horizontal line. In figure 5.4, at the value of the interest rate I, chosen by the central bank. In the next slide, we will look at these relationships graphically. Figure 5.5 illustrates the Islm model. Putting the IS and LM relations together. IS relation is given by the equation y equals c within bracket y minus t plus I within bracket y comma I plus g. LM relation is given by the equation I equals I bar. The IS and LM relations together determine output. Diagram on the next slide shows any point on the downward sloping IS curve corresponds to equilibrium in the goods market. Any point on the horizontal LM curve corresponds to equilibrium in financial markets. Only at their intersection, point A, are both equilibrium relations satisfied. Figure 5.5 holds the answer to many questions in macroeconomics. It allows us to study what happens to output when the central bank decides to decrease the interest rate, or when government decides to increase taxes or reduce spending, or when consumers become more pessimistic about the future, and so on. Figure 5.5, the Islm model. Equilibrium in the goods market implies that an increase in the interest rate leads to a decrease in output. This is represented by the IS curve. Equilibrium in the financial markets is represented by the horizontal LM curve. Only at point A, which is on both curves, are both goods and financial markets in equilibrium. At any other point other than A, either the goods market or the financial market or both would be out of equilibrium. Together, IS and LM determine output and interest rate at which both markets are in equilibrium at point A, where the two curves intersect. This is a very useful diagram for understanding impact of fiscal and monetary policies. Fiscal policy measures shift the IS curve. Monetary policy shifts the LM curve. Fiscal policy. Fiscal policy is implemented through changes in G or T or both, where G refers to government spending on goods and services and T refers to taxes minus transfers. A reduction in the budget deficit achieved either by increasing taxes or by decreasing spending or both, that is, decrease in G minus T implies fiscal contraction or fiscal consolidation. Symmetrically, an increase in the budget deficit achieved either by decreasing taxes or by increasing spending or both, that is, increase in G minus T implies fiscal expansion. Steps for analyzing the effects of changes in policy or exogenous variables. Using the Islm model, we can analyze the effects of changes in policy or exogenous variables. When you answer this or any question about the effects of changes in policy, or more generally, changes in exogenous variables, always go through the following 3 steps. 1. Does it shift the IS curve and or the LM curve? 2. What does this do to the equilibrium output and the equilibrium interest rate? 3. Describe the effects in words. Figure 5.6 shows the effects of an increase in taxes. Step 1. See which curve shifts. As you saw before, increase in taxes shifts IS curve to the left. In words, increase in taxes decreases disposable income and hence consumption. Equilibrium income will go down by a multiple of the initial decline in income. Economy moves from point A to A prime. Before the increase in taxes, the equilibrium is given by point A at the intersection of the IS and LM curves. After the increase in taxes and the shift to the left of the IS curve from IS to IS prime, the new equilibrium is given by point A prime. Step 2. Effect on equilibrium output and interest rate. Output decreases from Y to Y prime. By assumption, the interest rate does not change. Thus, as the IS curve shifts, the economy moves along the LM curve from A to A prime. The reason these words are italicized is that it is important always to distinguish between the shift of a curve, here the shift of the IS curve, and movement along a curve, here the movement along the LM curve. Note, change in taxes has no effect on the LM curve. In general, a curve shifts in response to a change in exogenous variables that appear directly in the equation for that curve. Step 3. In words, at a given interest rate, the increase in taxes leads to lower disposable income, which causes people to decrease their consumption. This decrease in demand leads through a multiplier to a decrease in output and income, and by implication a decrease in investment. Now we turn to monetary policy. Suppose the central bank decreases the interest rate. Recall that to do so, it increases the money supply. Such a change in monetary policy is called a monetary expansion. Conversely, an increase in the interest rate, which is achieved through a decrease in the money supply, is called a monetary contraction or monetary tightening. Monetary policy is implemented through changes in the money supply by the central bank. Monetary expansion through an increase in the money supply leads to lower I. This causes LM curve to shift down. Monetary contraction or tightening through a decrease in money supply leads to increase in I. As a result, LM curve shifts up. The change in the interest rate does not change the relation between output and the interest rate. It does not shift the IS curve. Figure 5.7 shows the effects of a decrease in the interest rate as a result of an expansionary monetary policy. Step 1. The reduction in the interest rate leads to a downward shift in the LM curve. In general, a curve shifts in response to a change in exogenous variables that appear directly in the equation for that curve. Monetary policy does not affect the IS curve, only the LM curve. The economy moves down along the IS curve and the equilibrium moves from point A to point A prime. Output increases from Y to Y prime and the interest rate decreases from I to I prime. Step 2. Effect on equilibrium output and the interest rate. New equilibrium output is higher While new equilibrium interest rate is lower, the economy moves along the IS curve from A to A prime. Step 3. Inwards. Increase in money supply leads to a decrease in interest rate. Lower interest rate leads to increase in investment and in turn increase in demand and output. Now consider the effect of monetary expansion on the components of demand. Consumption C increases because income increases. Government spending G remains unchanged. Investment I definitely increases since output Y is higher and interest rate I is lower, and they both lead to an increase in investment I. So both consumption and investment increase. We have looked so far at fiscal policy and monetary policy in isolation. Our purpose was to show how each worked. In practice, the two are often used together. The combination of monetary and fiscal policies is known as the monetary fiscal policy mix, or simply the policy mix. Section 5.4. Using a policy mix. Monetary fiscal policy mix is the combination of monetary and fiscal policies. Suppose that the economy is in a recession and output is too low. Both fiscal and monetary policies can be used to increase output. Sometimes the right mix is to use fiscal and monetary policy in the same direction. So for example, when the economy is in a recession and output is too low, then both expansionary fiscal and monetary policies can be used to increase output. This combination is represented in figure 5.8. Figure 5.8 shows the effects of a combined fiscal and monetary expansion in steps. Step 1. The fiscal expansion shifts the IS curve to the right. A monetary expansion shifts the LM curve down. Step 2. Both lead to higher output. Economy moves from point A to A prime and equilibrium output increases from Y to Y prime. Step 3. Inwards. As a result of using expansionary fiscal and monetary policy together, equilibrium output is higher and interest rate is lower. However, fiscal and monetary policies have different effects on the composition of output. A decrease in income taxes tends to increase consumption relative to investment. A decrease in the interest rate affects investment more than consumption. Thus, depending on the initial composition of output, policymakers may want to rely more on fiscal or more on monetary policy. Why should both policies be used if each one alone can be used to fight a recession? In case of fiscal policy, high debt may prevent the government from increasing spending or reducing taxes as much as they would need to. Similarly, the liquidity trap or zero lower bound limits monetary policy. Focus box. The US recession of 2001. Figure 1 shows the US growth rate for each quarter from 1999 Q1 to 2002 Q4. The National Bureau of Economic Research concluded that the US economy was in a recession between March 2001 and December 2001, shown by the shaded time period, triggered by sharp declines in investment demand. The vertical axis is labeled growth in real GDP percent and ranges from negative 0.5 to 2 in increments of 0.5. The horizontal axis represents the set of 4 quarters from the years 1999 to 2002. The estimated growth rate of the US in the 4 quarters of the year 2001 is as follows. Quarter 1, negative 0.3%. Quarter 2, 1.65%. Quarter 3, negative 0.25%. Quarter 4, 0.85%. Figure 2 shows the behavior of the federal funds rate from 1999 Q1 to 2002 Q4. Starting in early 2001, the Fed, recognizing that the economy was slowing down, started decreasing the federal funds rate aggressively. It continued to do so throughout the year. The rate, which stood at 6.5% in January, was less than 2% at the end of the year. This is an example of the use of expansionary monetary policy to stabilize the economy. The vertical axis of the graph is labeled percent and ranges from 0 to 7 in increments of 1. The horizontal axis represents the set of 4 quarters from the years 1999 to 2002. The estimated federal funds rate in the 4th quarter of the year 2000 is as follows. Quarter 4, 6.5%. The estimated federal funds rate in the 4 quarters of the year 2001 is as follows. Quarter 1, 5.7%. Quarter 2, 4.4%. Quarter 3, 3.6%. Quarter 4, 2.2%. The estimated federal funds rate in the 1st quarter of the year 2002 is as follows. Quarter 1, 1.8%. Figure 3 shows US federal government revenues and spending as ratios to GDP from 1999 Q1 to 2002 Q4 as a result of the recession, events of September 11, 2001, and fiscal policy measures taken to deal with the recession. In addition to monetary policy measures taken by the Fed, President George Bush also cut taxes in 2001 and 2002 budgets. The events of September 11, 2001 also led to an increase in spending on defense and homeland security. Note the dramatic decrease in revenues starting in the 3rd quarter of 2001. Even without decreases in tax rates, revenues would have gone down during the recession. Lower output and lower income mechanically imply lower tax revenues. But because of the tax cuts, the decrease in revenues in 2001 and 2002 was much larger than can be explained by the recession. Revenues declined and spending increased not only because of the slowing economy, but because Congress implemented an expansionary fiscal policy by cutting taxes and increasing spending. The effects of a combined fiscal consolidation and a monetary expansion, using the two policies in opposite directions. Figure 5.9 shows the effects of a combined fiscal consolidation and a monetary expansion. The fiscal consolidation shifts the IS curve to the left. Economy moves from A to A prime. Output falls from Y to Y prime. However, if the fiscal consolidation is combined with a monetary expansion, it shifts the LM curve down. Economy moves from point A prime to A double prime. Equilibrium output increases to Y double prime, same as the level Y before the fiscal consolidation. This allows for the reduction in the deficit without a recession. If the government reduces the deficit, say by increasing T or by decreasing G or both, the IS curve will shift to the left from IS to IS prime. the equilibrium will be at point A prime with the level of output Y prime. At a given interest rate, higher taxes or lower spending will decrease demand and through the multiplier decrease output. Thus, the reduction in the deficit will lead to a recession. The monetary expansion will shift LM down, output will increase to Y double prime, same as before. Together, they leave output unchanged while the budget deficit is reduced. Focus. Deficit reduction. Good or bad for investment. Equilibrium in the goods market implies, recall chapter 3, I equals S plus within bracket T minus G, where S represents private saving and the term T minus G equals public saving. So in equilibrium, investment is equal to private saving plus public saving. If public saving is positive, the government is said to be running a budget surplus. If public saving is negative, the government is said to run a budget deficit. So it is true that given private saving S, if the government reduces its deficit either by increasing taxes or reducing government spending so that T minus G goes up, investment must go up. However, a fiscal contraction lowers output and so private saving S goes down. The contraction leads to lower output and therefore lower income. As consumption goes down by less than income, private saving also goes down and by more than public saving, T minus G increases. So investment I decreases. Short-run implication of deficit reduction is lower investment spending in the economy in the short run. Try to do the algebra to see why this is true. Does this mean that deficit reduction always decreases investment? The answer is clearly no. We saw this in figure 5.9. If, when the deficit is reduced, the central bank also decreases the interest rate so as to keep output constant, then investment necessarily goes up. Although output is unchanged, the lower interest rate leads to higher investment. Whether deficit reduction leads to an increase in investment is far from automatic. It may or may not, depending on the response of monetary policy. Section 5.5. How does the Islm model fit the facts? Because the adjustment of output takes time, we need to reintroduce dynamics. For example, when looking at the effects of an increase in taxes in figure 5.6 or the effects of a monetary expansion in figure 5.7, we made it look as if the economy moved instantaneously from A to A prime, as if output went instantaneously from Y to Y prime. This is clearly not realistic. The adjustment of output takes time. To capture this time dimension, we need to reintroduce dynamics. Consumers are likely to take time to adjust their consumption following a change in disposable income. Firms are likely to take time to adjust investment spending following a change in their sales. Firms are likely to take time to adjust investment spending following a change in the interest rate. Firms are likely to take time to adjust production following a change in their sales. Figure 5.10 shows the empirical effects of an increase in the federal funds rate. Figure 5.10 shows the results of an econometric study which uses data from the United States from 1960 to 1990. The study looks at the effects of a decision by the Fed to increase the federal funds rate by 1%. Each panel in Figure 5.10 represents the effects of the change in the interest rate on a given variable: retail sales, output, employment, unemployment, and prices. Each panel plots three lines. The solid line in the center of a band gives the best estimate of the effect of the interest rate change on the variable, and the two dashed lines and tinted space between them represent a confidence band within which the true value of the effect lies with 60% probability. The first graph labeled A represents the effects of 1% increase in the federal funds rate on retail sales over the time of 12 quarters. The largest decrease in sales, negative 0.9%, occurs after 5 quarters. The second graph labeled B represents the effects of 1% increase in the federal funds rate on output over the time of 12 quarters. In response to the decrease in sales, firms cut production, but by less than the decrease in sales. This is because firms accumulate inventories for some time, so the adjustment of production is smoother and slower than the adjustment of sales. The largest decrease, negative 0.7%, is reached after 8 quarters. In other words, monetary policy works but with long lags. It takes nearly 2 years for monetary policy to have its full effect on output. The third graph labeled C shows that lower output leads to lower employment. As firms cut production, they also cut employment. As with output, the decline in employment is slow and steady, reaching negative 0.5% after 8 quarters. The graph labeled D shows the decline in employment leads to an increase in the unemployment rate. The graph labeled E represents the effects of 1% increase in the federal funds rate on price level over the time of 12 quarters. Remember, one of the assumptions of the Islm model is that the price level is given, and so it does not change in response to changes in demand. The estimated percentage change in price level is as follows: quarter 1, 0, quarter 3, 0.1, quarter 4, 0, quarter 8, negative 0.1, quarter 11, negative 0.3. So it shows that this assumption is not a bad approximation of reality. The price is unchanged for the first 6 quarters. Only after the first 6 quarters does it decline. Taken together, all the panels show that in the short run, an increase in the federal funds rate leads to a decrease in output and to an increase in unemployment, but it has little effect on the price level. Figure 5.10 supports the assumption of fixed prices and the assumption that in the short run, production responds to demand without a change in prices, and therefore output depends on demand in the short run. This also gives us a strong hint as to why the Islm model becomes less reliable in the medium run. We can no longer assume that the price level is given, and movements in the price level become important.